of those is the flexibility in selection of spans length, numbers and location of the peers, and also the segments length and splice locations. Also, one of the methods that is being used for this method is full length post tensioning. Okay. Okay, so in this presentation we'll see how simply we can model this pre-stressing and post-tensioning in the same model simultaneously, and then defining the construction stages, because this type of bridges is all about the construction stages. And then after that, I will show you how user-friendly is our graphical interface of our software Midas Civil, and then show you how to extract the results. Okay. The objectives today are going to, as I mentioned, having an introduction, and then going to the bridge geometry and material properties. So in this way, I'm going to define material properties and sections, and then creating the geometry and defining the time-dependent material for creep and shrinkage, as well as compressive strength of concrete. And then I'll show you how you can activate and deactivate supports, because some of them are temporary, some are permanent. And then applying loads, and then defining construction stages and analysis, and at the end we're going to results. The bridge that I'm going to model today, you can see the elevation and plan here. It consists of two parts. You can see in the middle section here, this is a post-tension box girder, which is cast in place, and the two at the left and at the right, we have I-girder precast, pre-stressed. So this is a combination of those, and you can see the length 100 feet on the left and right, and 44 feet in the middle section, and the width of the bridge is also 67 feet. And as you can see here, this bridge is slightly skewed, but that's, we could ignore that, but for just showing you how we can model the skewness here, I will have this skew here. It's a very small value. And the cross section, we have two types of sections. One is bulk tees, which you can see in the right side, and another one is the post-tension multi-cell box girders. So I will model these two for you in the software. And next one is the applying the tendons. So and in this slide you can see we have three construction stages. In the first construction stage, we have only the pier and the box girder in the middle span, the middle section, and then we are adding the I-girders to the left and right, those bulk tees, and we have the temporary supports here. And as you see, we have pre-stressed tendons you can see them in the left and right, on these I-girders or bulk tees. But in the next stage, we can see we have the post-tensioning tendons, and when we are applying these post-tensioning tendons and then pull them, we can remove this temporary support, and you can see that bridge is completed and you can apply your load. Okay, so I start modeling. So let me just open the software Midas Civil. Okay. This is a general GUI of Midas Civil. Here is, let me open a new project. Okay. Here in this wide screen is your model view, and you can create your model, your section, and everything that you're creating. You can see it here visually. In the top we have some menus, the general menus, and we have these ribbon menus, which make it very easy for modeling. So you can see by clicking on these tabs, you can go to the different parts. On the right side, you have the views and edit icons, help you in the zoom in, zoom out, or seeing the different angles. Down here is the message window, which tells you what's going on in the modeling, if you do any mistakes or there is some problem with the boundary conditions or anything, it will tell you. So it's a kind of communication between the software and the user. And in the left side, in this section, you can see the tree menu, which one of the best part of our software, in a way that you have a couple icons, and let's say in a work icon, you can see whatever you are modeling or defining, you will see that it will show up here. So as I go, I will show you how you can see it here, and it makes it very easy for you to check if you've done everything correctly, and also make it easy for another engineer to check your work. Okay, so the first step is going to be defining the material. I'm going to have 3 types of concrete material and 1 steel for those tendons. So it's very easy, just right click on the model view and go to the properties and material. So in the material you can just press add, and the software gives you an option to select steel concrete or user defined. For now I'm going with concrete and name it concrete 6000, and selecting from this database, going to the grade 6000 and press OK. So I have 1 material is defined, and as you see on my tree menu, my first material is created here. Okay, for saving time, I'm just importing my other material from my previous project, which I had, and I show you also how easy to get it. So if I have my project here, okay, so these are the 4 sections material which I defined previously. So I have it here, and just press OK, and you see by 1 click you have all your material. Now I'm going to sections and defining my section. As I showed you, we have 2 sections. One is bulk tees, which is composite, and another one is box girder. So I'm going to model the bulk tee for you, and the bulk tee is actually composite. But the point is, here with help of construction stages, we are modeling this structure in a way that software can calculate the before composite behavior and composite behavior. So the section property, everything will be changed. So for this reason, I'm going to select, you see we have several options to select here. First I'm going to the PSC, and then defining my bulk tee. And from here I can select my bulk tee is 60, and just let me name it, called bulk tee 60, and OK. Alright, you see that 1 section is defined here, but this is not still the composite. So I have to again go to my section, select the composite, and in this composite I have to select composite I, and now you can see it's going to be 1 I girder or T girder or bulk T girder, and then topping or the concrete on top of that. Okay, so I need just to import my values for that. My slab width total is 900. Oh, I'm in the feet, so I gotta change it to, because I have my values in feet, in inches. So I can switch it to inch. So another good feature of midas Civil is that anytime during your modeling, you can switch your units from one to another without any change in your total model. Okay. Pressing add, composite I, and now I simply can enter my values. 900 inch, 10 girders, center to center going to be 90, and slab width is 90 inches, and thickness 7 inches, and these are connected, and this one going to be 1.5 0.22. And for my bulk T, so simply because I already defined that, I don't need to define it here, because software gives me an option to enter my values here. But also, if you previously defined that, you simply can import it. So import, and it will show up here. Okay, so I forgot to put the section's name. Say Bob Composite. Okay. Alright, my sections are created here, so I'm going to work with this. For saving time, I'm going to import from my previous project. And as you see, we have all our sections defined. I'm pressing OK. We have all the sections. Okay, close. The next step is going to generate this geometry. Okay, so for that reason, I start by defining the nodes and elements, because there are several ways to do that. I'm going to just show you from scratch if you're going to define your nodes and then assign your elements. For that reason, I right-click on the model view, going to node, create node. So for that creating node, I select 0, 0, and then 10 times. I want it to repeat that. And in the y direction, I'm going to go 6.75. X and y, 6.75. Okay, and apply. So if I switch to the top view, you see that 10 nodes are created. As I mentioned, this bridge is slightly skewed, so let me show you how you can model those skewness. So going to the node and then rotate, we can select all nodes, and then here it asks me the angle of rotation. So I'm going with a negative 2.5 degree about the z-axis, because we are in the plane of the x, y, and then it's going to rotate about the z. And before that, we can copy or move, apply, and you see that it's rotated. Okay, the next step going to generate these elements. So right click, going to the element, and then extrude. So this extrude gives me an option to create elements from nodes. So it's very simple. We can select our material, and for now I'm selecting this dummy beam because it doesn't have any dimension. And so the software gives me the option to have like equal distances or unequal distances. In this example, we don't have equal distances, therefore I will go with the unequal distances. So you can have different distances in one shot. So I'll show you how to do that. We're going to be in the x direction, and then the distance is going to be a spans of 13.5 4 at 11, and again 8 at 13.5. Ensure everything is correct. Okay, then pressing apply. Okay, first I have to select my nodes, and now apply. So simply you can see that all the elements are created, and then the next step is to define these cross beams or the transverse elements. So the same thing, this time I'm going to select these nodes in the bottom, and then right click, elements. Actually I have it here, so I don't need to do that. So selecting the same thing, and then this time it's not in x direction, it's not in y direction. So I select from this node to this node. So by selecting two nodes, it gives me the the direction. Okay, I want it 10 times, and pressing apply, everything is created. Okay. Next thing going to be, so if I show you in this way, we have our superstructure created. So one more thing I need to do is to define two nodes for my peers. So the peer, close. I can select, I know that my peer is going to sit under this location and this location. Okay, for this reason I selected these two nodes and right click, going to nodes and then translate. So in this translate, it gives me an option to equal distances and -8. Copy and apply. And if I switch my view, you can see that two nodes are created down here. So technically you can switch your view and see how it works. So in isometric view we have that. Okay, so it's very easy to generate those peers. We have two peers, so simply we can select these two and right click, go to the element, extrude, and then simply extrude them. Equal distances, -20, and apply. Oh, I selected the wrong sections. And select previous and apply. So anytime you're doing any mistake, don't worry about that. You can use the Control-Z or undo section. It starts from the beginning, and anytime you want, you can just redo and undo unlimited times. Okay, so I'm going to open another file which I have created and then start from that point. Okay, complete geometry. No. Right. So here is my entire bridge, substructure and superstructure. So actually define these sections. We're gonna go ahead and show you how the bridge looks like. So here in the middle section, you can see your bulb tees. Let me close and turn this off, so you're not seeing the nodes. Okay, it's better view. So here are the pre-stressed precast eye girders, and in the middle section you have your box tees. So it's very simple to see different views. Actually, I can just double click on these bulb tees and deactivate that, and then whatever you have here, you can see your box tee. Okay, let me just activate all. Let's say activate this one. Okay, here are my bulb tees, my box sections. We can go open and close. So this feature of the activation and deactivating is very helpful in terms of modeling, because sometimes it's very hard to select one element from a tons of elements that is there. So I can activate that. Nothing is changed. Geometry is the same and model is the same, but the only thing is changing is just the view. Alright, so here was a tapered section in the middle, you saw that. And it's very easy if you want to change your sections. Let's say I'm going to change my section, this one. I can simply select these two and these. Okay. And I'm going to just change these to, select them all, to the, let's say, external box girder. So drag and drop it here, and you can see simply it will change everything. So you can select previous again, and then you can go back to whatever you had. Let's say bulb tee or anything else. So simply I can undo that and go back to my original file. Okay. So the first part is done. Next thing I'm going to show you is how to define the tendon profile, tendon properties, and how to assign it to the elements. Okay. Let me close this. And before that, I forgot one step. Let me tell you how you can define the time-dependent material. So it's very simple because in this software you can perform the time-dependent material analysis, and for that reason we need to define some time-dependent properties. So we go to the properties and material and time-dependent material. So you have two parts. One is for creep and shrinkage, and one is for compressive strength. So let's go to the creep and shrinkage. We can add, we can name it anything, and then you have several codes to select them from. It's CB, FIP, 1990 and 1978, and ACI, PCA, and so more. For now, let's stick with the 1990 because it's been used by a lot of designers. And then we can define the compressive strength of concrete in KSI, let's say 6,000. And then notational size, let's stick with 10 for now, but software has the option to automatically update these notational size by checking these sections. Okay? And then when you're defining this, you can go to the show result, and you see you have creep and shrinkage. These are the two graphs which showing the results based on the input that we entered, and also based on the codes that you selected. Okay? For now, we already defined that, so I'm not going to add anything to this. Also, for the compressive strength of material, of this concrete, you can add, so that compressive strength. We can select any code you want. You can go with the CBFIP or ACI and enter your values. So here 750 KSI, correct, and then draw a graph. So you have your compressive strength, nonlinear compressive strength, which is time dependent here. Okay. And then simply you can assign it to your elements that you want. This is one thing which I wanted to show you, and the next step is going to be defining the tendon properties. Okay, for that reason, we need just to go here in the stage and then press on the tendon properties, add tendon name, let's say tendon part and 1, 2. Then you have option to say it's internal pre-tension, internal post-tension, or external. So for now we're going to post-tensioning. Material, we can select from the material that we define, and you can see actually the properties here. You can go here and check the material properties or change them. And the tendons, I'm going with 20 half an inch. Okay, so it automatically calculates that for me, and the duct diameter say 2.5 inches. And for the CBFIP and 2.5 for relaxation coefficient, and everything looks good. You just press OK, and my first tendon is defined, tendon property is defined. So similarly, you can define more tendon properties, but for now I just stick with one of them. And now I want to define this tendon profile. So right click on, click on this icon, add, and you have several options. So one of the options is to, if you have your coordinates in Excel sheet, so you can simply copy paste it. So I actually have those values in my Excel, so I simply copy them and bring user detail. Okay, let's say name it, let's say lane L1. Tendon property is the one from the one that we defined. We already have one of them. Assign elements, so I can switch to the top view, turn this off, and say that I'm going to apply for these elements. Okay. And also, if you know your element number, you can simply type them here. 3D, spliced or round, stickle spliced, and then straight, and paste here. Okay, so when I'm pasting here, you can see your the geometry, tendon profile is created up here. You can see that in a Y and Z plate. Okay. So now I'm going to fix some points which are I want to be fixed. Let's say this one I want to be fixed. I want this one be fixed and this one be fixed. Okay. Everything is okay, and press apply, and it's already applied. So if you have more tendon profile which you want to define, you can simply do that. And the software gives you a lot of options to copy paste these tendon profile and make it very easy. If you want to rotate that or do anything with these tendons, simply you can do that. Okay, let me simply show you this one. Go back to this view, and you can see that it's been defined here. And if I go to the side view, you can see its profile. Alright. So for saving time, I'm going to show you, if you have your values in the tendon profiles in a text format, you can simply import it in the software. So for that reason, you can simply go to the tools, enter the command shell, and then bring it in, tendon profile, okay, and say run. So in by one click, you have 81 profile is defined. So let me remove this one which I defined. I don't want to make confusion. So totally we have 80 tendon profiles, and the reason for having these 80 is that we have defined the pre-stressing. Let me show you again. On the left side and right side, as I mentioned, they are like a precast pre-stress. So we need to define tendon profile for them, as well as we have post-tensioning tendons, which goes through entirely bridge and makes it as a continuous structure. So totally we are coming up with the 80 tendon profile, which you can see here. And also, if you have your tendons in AutoCAD, you can simply go here and then tendon profile generator, and here you can just import from your DXF file, and simply you can have all your tendon profiles very simply and in a very shorter time. Okay. So the very last step for these tendons is to applying the load on them. So tendon pre-stressing load. Okay. So tendon pre-stressing load. So we can simply define that. So before applying the loads, I have to define actually some load cases. So for that reason, right-click on the screen, go to the load and static loads. So I can, let's say the first one going to be self-weight. The type of that could be dead load. Add. Second one could be PS load. And the type of that is pre-stress. Or we could have a wearing surface. And any, what did I type? Surface. It could be again dead load and add. Okay, for now I'm just defining these. Now simply we can go to the tendon loads, and that for that reason it would be PS load and default, and I can select any tendons which I'm going to apply this load on that. Let's say I'm going to apply for the first 3 of them. Add it, and then you have 2 options to add stresses or forces. So simply you can select either one that fits better for you. So I'm going with stress, and I have option to select from beginning or end or from both sides. So this is the actually jacking. So I want the jacking be from both sides, and then beginning going to be 200 KSI and end 200 KSI, and grouting after 0 days, and add. Okay, so now I defined my loads on 3 of my tendons, and simply you can do the same for the rest of your tendons. Also for these, for the rest of the load cases, for let's say for self weight, I can simply go to the loads, self weight, and then say -1, add, and self weight is activated. So some people like to add the self weight as like a distributed load later on, so they can set it as 0 and then add the self weight as a normal load. So some people like to, for some elements, they need to define the self weight. So you have this option to activate or deactivate it for some elements. Okay, so let me open another file which already completed everything on that for the tendon profiles. So going to the complete tendon and loads. Okay. My structure is here, and let me remove this, and I want to show you how to model this stuff. Okay. So in this step, I'm going to show you. All right. Until now, we have entirely structure, substructure, superstructure, tendon profiles. We applied the loads, and now the next step is going to be moving loads. Okay. How to define the moving load and how to define the vehicles, select the codes, and defining my lanes, number of lanes, and all this stuff. Okay, for that reason, I'm going to the moving tab, pressing on this vehicle here. It asks me for a code, so I have option to select from a variety of codes which I have here. Now we go with the H2 LRFD. Okay, as I selecting the code, so the rest of the elements will be activated. Now I have 2 options to select traffic lanes or traffic surface lane. Sorry, line lanes or surface lane. So because here we have beams, we have to go with the line lanes. Okay, so let me switch to the top view. I'm pressing that, add, and now I can simply define my traffic lanes. So I call it lane 1, and then eccentricity. So okay, simply if you have your if you know where exactly to apply your lane, so you can simply go ahead and do that. If you don't, and you have the if you don't have it, you can always go with the surface with the reference line. Now I'm going to show you how to create these lanes from the surface line, reference line. Okay, for the eccentricity, first one going to be -15.75, and the wheeling space 6, and moving the direction should be from both sides, and selecting 2 nodes. This is going to be, by this node, we are defining our reference line. Okay, let's say, let me delete this, selecting from my crossbeam, and then again from here to here, and apply. So you can see my first lane is defined. So for now we can do something. We could ignore that skewness, or we can define that. So for that reason, I can simply here in the skews apply 2.5, which I showed you in the beginning, and then 2 points from here to here, and apply. You can see that it's exactly following that skewness. Okay, so I have another lane going with lane 2, changing the eccentricity, adding 12 to that, going to be 27.75. The same thing, the skewness the same, and then reference line from here to here, apply, and I have my second lanes, and so on and so forth. We can go ahead and apply the rest of the lanes, but for now, for saving time, I'm not doing that, and just defining 2 of them. And now I can select my vehicles as a standard. For LRFD, I'm going to define 1 trunk and 1 tendon. Okay, close. And then from here, moving load cases. So I call it moving load case 1, independent, and add. So here I can select from 2 lanes, and then number of cases 0 and 2. Okay, so it's completed. As you see here on the tree menu, some of these, these 2 vehicles, I just applied the vehicle 1 to my lanes, and now you can see it's in the black color. But another one, the truck, tendon is in black and truck is in the blue color. So blue color, whenever you see the blue color in your tree menu, it means it's not assigned to this structure yet, or it haven't been used. Okay, so the very last step is to define construction stages. As I told you, this type of structures is all about construction stages. So I'm going to show you how simply you can define your construction stages. So for that reason, I switch to this stage. Go to this view. Okay. Just press this button, and then generate name. I call the stage suffix from 1 to 4. Stages, and okay. Okay, so 4 stages are generated. So simply I double click on that. On stage 1, it stay here, and the duration is going to be 30 days. And what I'm going to activate here, so in this window, you can activate and deactivate your elements, boundaries, and loads. So for at the stage 1, actually we have only our pier and that box girders in the middle. So what I'm going to do, adding pier, 60 days, add, and the next one going to be box girders, and add. Okay, 2 of my structures are added. Going to the boundaries. For boundary, what I have to add is pier supports, add, false work supports, and box girder rigids. So these are actually the temporary support which I have to apply that. So going to the load tab, we have only self weight. Okay, just activate self weight and say add. Alright, so simply we can go to the let's say apply, and then switch to the stage 2. In stage 2, which has a duration of 20 days, in this stage we have to place our PC girders, precast girders. So let's go to the elements, PC girders, which have already age of 14, and then cross beams. So we are casting these cross beams to place them in the same place. At going to the boundaries, we have beam end release, because for the when we actually have the temporary support and we haven't applied that post-tensioning tendons yet, these eye girders are behaving as a simply supported at both ends. And after we're pulling them, that's going to be like a continuous structure. So for now, with the beam end release, that beam end release means we can actually control the behavior of each element, which for this reason I released the moments on one end of some of the elements. Okay. So it's going to be beam end release, abutments, and the PC girder rigids. And then in the load tab, we have our deck activated and pretensions. Okay, let's say apply, and then switch to, so stage 3. Stage 3 has duration of 60 days. We are not adding any element to that, so element stays empty. In the boundaries, we have to add the beam end release. Actually, we have to deactivate that. So beam end release goes to the deactivation group. So we see activation and deactivation. So this in the stage 3, we are actually pulling these tendons, post-tensioning tendons, and then removing those supports. So beam end release goes away, and it's going to be a continuous member. Also, false work supports, we have to deactivate that as well. And the load, we are adding sidewalks and post-tensioning. Okay, apply. And the very last stage going to be stage 4, which I'm giving a duration of 10,000 days, just in case to show you how you can see the result of creeps and creeps on this structure after 10,000 days. Okay, but we are not adding or activating or deactivating any element, boundaries, or loads. Say okay. So we have all our construction stages modeled here. So the very last step is to actually define that composite section. As I mentioned, that bulk tees behaving pre-composite and composite. So for that reason, we have to define for the software how to understand that. So for that reason, I'm adding this, and it gives you two options: element 1, which is bulk tee, and element 2, which is deck. So activation stage going to be stage 2. For that element, I'm selecting material for part 1. Part 1 is a bulk tee. Materials is grade 6000. Activation stage going to be the same as this, stage 2, so I keep it like that. And the age going to be 14 days. The notational size is updated. You can see here. And for the second one, we go with the material grade 4000 for the deck, and activated as the stage 3. Okay, so in stage 2 we have only the bulk tees, which has the which doesn't have the deck, so it's only the bulk tee. And in stage 3, that deck will be added. Is actually the concrete is dried, and it has the strength, so it behaves as a composite section. Okay, and the age 20 days. Apply and close. Okay, this is also created. and simply we have to, we are ready to perform the analysis. So going to the analysis and analysis control, we have two type of analysis running on this structure. One going to be construction stage analysis, because we define these construction stages and want to know what's the result. Okay. Okay. We can select all these. Alright, and then initial 0. Okay. And then for the moving load control, you can see here, okay, let me just check the normal and concurrent forces. In this way, software gives me the concurrent results, which means you can see the shear moment and the axial forces at each element at the same time. For example, if you see the one element has the maximum moment on that, you can find the axial load and the shear on that. Okay. So now we simply press this run button and it's ready to perform the analysis. It takes a couple of seconds to perform the analysis, and meanwhile okay, so in this message window you can see the process of analysis, and simply you can check it out here. You can check out if there is any error message or warning message. So sometimes you haven't defined your boundary conditions correctly, or there is other problems, so software simply tell you what to do about them. Okay, so it's finished for the 6 seconds for performing the analysis. Okay, so let me show you some of the results. Make this smaller. Okay. So we go into the results and forces beam diagram. Let me just show you some results for a self-weight, bending moment based on self-weight, and then legend and apply. This is the post tension. Okay. So in different stages, you can see the bending moment, bending moments. Let's say for stage 1, which you can see there is only my post tension box girder. Stage 2, stage 3, stage 4, and after composite. Okay. So simply you can select the type of load that you are interested in. Let's say you are interested in to see construction stage maximum creep secondary or creep primary effect. So you can simply select that and press apply. It gives you the primary and secondary effects of creeps, primary secondary effect of tendons, and shrinkage. You can simply check those, and it's very easy to get the results in the tabular format. In this way, you need just to click on this button and ask you what load cases are you interested in. Let's say you want just a creep primary, creep secondary, and head load. And then for stages, you can select which stages are you interested in. Let's say stage 3, 4, and press OK. And you're going to have a chart here. Shows you all the values. So okay, so here, so the values are very small. Let me switch to inch and pounds. Okay, there you go. So simply, as I mentioned, you can switch your units. Oh, okay. Here you can see your axial force, shear in the y direction, shear in the z direction, torsion, and bending moments. And simply, if you are interested in, let's say, your bending moment in Z direction, you can arrange that, sort it based on that one. So it's a sorting diagram. And whatever is important for you, let's say your moment Z is important, you add it to the right list, and then take it to the top priority, and then say sort. So automatically it's sorted for you. So it's sorted based on the ascending method. Okay, now here you see your maximum moment based on this load is happened in the element 339, and you can check your concurrent forces on that element when it happens to have this much of moment. Okay. Maybe back to the model view, and you can also see the tendon losses. Let me go to the results. Tendons and tendon losses. So in each stage, let's say stage 1, you have this much of losses, and as you see, oh, where I am? I close that. Let me go again. Tendon losses. Okay, there you go. Who's closing? Let me just give me a second, please. Okay, let me switch to this one. Okay, here you can select your tendon, and then your stages, let's say for stage 3 or 4, and then simply you can apply these. For some reason I'm getting a 0 values. Probably I have to actually perform analysis on my complete model, because here we haven't completed the analysis, because here you have only 2 vehicles and it's not as it is, and I didn't apply the load on the pre-stressing tendons. So I better open my final file, which is complete analysis. And now here I can show you, because as you remember, I just applied tendon loads on only one of them. Okay, so here I can see the results and tendon losses. Apply tendon loss forces. Okay. I can show you also the in the moving loads. The one good feature about the software is that anytime you see you are interested to know what's the maximum effect on the one element occurring from the moving loads, so you can simply go ahead and check the load pattern which caused that moving load. So which is called moving load tracer. So for that reason, I come here and select beam force moments based on moving load tracers. It's a key element. So I say, let's say, check this element 5, and apply that. So you see that this load pattern, when the vehicle is staying here, is causing actually the maximum effect on this element. So if I change that and say I'm interested to see what's the load pattern causing the maximum, let's say bending moment or minimum bending moment, so you can have option to select one of these. Let's say apply, and you see that different load pattern is showing up here. And so much more, and for the time concern, I'm just trying to finish this session today. And please feel free to send me email on my, let me open this one for you. you're gonna have my email address. Okay, so yeah, as a summary, just let me quickly go through these. Today we learned how to, what is the spliced girders, and then how to define the time-dependent material properties in midas civil, how to model post-tensioning and pre-stressing at the same time in the same model, and how easy it is to get your tendon profile defined in midas civil, and then if you have your text format, you can import them. If you have in Excel sheet, you can copy paste them. If you have in AutoCAD, you can simply import them, okay? And how flexible, quick, and easy it is to define the construction stages, and it's very realistic. You can exactly step by step define those construction stages. How to get the primary and secondary effect of creep and shrinkage, and how user-friendly is to extract the graphic user interface. So simply those results could be copy-pasted in Excel or exported in Excel, and it's ready for design. Okay, thank you so much, everybody, for attending this webinar. And please feel free to send me email, or you can. I'll keep this session open for a while, and you can also use that chat box and send me your questions, and I try to answer those.